how does selection sort work and what it is. So basically, sorting is an algorithm where we sort the algorithm in a decreasing or increasing order. We arrange the array or any string in increasing or decreasing order. So uh, for example, we have an array like this, and we might want to sort this array in an increasing or decreasing order. Let me just sort this quickly. So in simple languages, the sorting means like this, but in the terms of computer science and programming, there are several methods to do sorting. Methods differ in ways like time complexity and space complexity. Mhm. So the one algorithm which we are going to discuss about today is selection sort. Uh, so basically, uh, the way how selection sort work is like this. Let me just explain it to you with an example. So here's our array. Let me just take it as an array. This is our array, and this is an array of 5 elements. So basically, in selection sort, we always take our first element as in current element, and then we compare it with the rest of the array, and do it till we find the smallest element in the array. Like in this, we have found 11, so we would just swap it. So here we will get 11, and here we will have 64. So this is how our selection sorters work. So there are steps to do this. So we will just write an algorithm, and first before writing algorithm, we should understand this how this works. So this is the step 0. So in the next step, we begin to compare with it. Like we have 64, 25, 12, 22, and 11, and we just compare our current element with the rest of the array. And once we find the minimum array, um, once we find the minimum element in the array, then we will just swap it. So here we find 11, and then now we will just swap it. So here we will get 11, and here we will get 64. And the good thing about, or you can say that's the gimmick of the selection sort, is that this portion of array becomes sorted with time. You will understand this in the next step. So this is it, step 1. Now we will begin step 2. So our current will move uh, to one place, to I plus plus. You can say that it plays one move uh, above the array. So this is where our current is at, and this is our sorted part of the array. And now we will begin to compare it with the rest of the elements. Then this, then this, then this, and the least part is this 12. So we will just swap it with it. As we can see, this part is automatically become sorted, and this is 25 here, and this is 22, this is 64, and we will do this again. Now we will search for the minimum element, which is 22, and now let's just swap it with 25. Now we will again search for the minimum element, but 25 is lesser than 64 and there are no elements left. So this is our sorted array by selection sort, and this is how our array sorted array look like if we did it with selection sort. Now we will understand the code. How will the code works and what would be its time complexity. Let me just write and dry run code here. Let me just make this function, and here we have our array. Uh, so uh, we have our array passed here in the function. Now we have to get the size would be like array dot size, according to the language you are doing. We have calculated the size. Now we will iterate the loop. So here what we have done is that we are going to iterate the loop over n-1. It means that let's suppose there are 5 elements, then we will iterate our loop 4 times. I mean lesser than 4 times, so our loop will stop here where the 2 elements are left, because it's a common sense that we don't need to compare these 2 elements. Like in this step, when we reach this point of the array, they were already sorted, so we didn't need them. So that to remove the excess amount of iterations, and so why should we do this? It's of no need, so we just don't do this iteration. And to skip that, we always do n-1, so it stops before the last 2 elements. Now in the for loop, we have took a min element. Let's just say it as min, which would be equal to I each time, as I will firstly I will be 0, then 1, then 2, and then so on according to the array. So always the minimum element will be the first one after the iteration. Now we will iterate another loop. This loop always starts after the I, and let's say we have I here, then the loop will start from here, then move here, then move here. It will work alongside with I will be static in an iteration. Then as we compare this I and with J will, like this is I would be compared with J. Is it small? Yes. And let's check for another I. Is there any element smaller than 12? 22 is smaller than 12? No. Is this? No. So that smallest element will be 12 here, which would be swapped. So for that we have to J like this. And now let's just, if array of J is smaller than array of min, then we just have to swap. Let's just swap. And this is it. It's simple. Now it's a very simple code, so we don't have to worry too much about. And the time complexity of it obviously will be O n square, because we have 2 loops here, as we can see. So these 2 loops will contribute to O n, so this will contribute to the O n square time complexity here. This is for this video. I hope you enjoyed it. Thank you. Subscribe to my channel if you like the video. We'll meet in the next video again. Bye bye.